You will be given problems with bearing with two different methods, so you need to understand how both methods work. Bearing is just a way of measuring angular rotation about any fixed point. So the first method is if you're just given an angle like 235 degrees. Then what you do is you identify where is due north. Here's north. Then you're going to rotate your second line 235 degrees clockwise. So we know it'll be someplace past. So if this is due south, that's going to be 180 degrees, so it'll be someplace past there will be that 235 degree angle. The second method, you actually begin with a north-south line. And you use an acute angle to show direction either east or west from this line. So if you have like north 64 degrees east. So you identify here's north. Now I have to head east, rotate east 64 degrees. So that's going to end up taking me, say, here. You can also do this from the south line. So if we have, for example, south, I don't know, 12 degrees west. Here's due south. I need to head in the west direction 12 degrees, so I know that's going to be a really skinny angle. That's how you do bearing, and this is what we see when we do word problems. So this is our first word problem. We're told that stations A and B are on an east-west line 8.6 kilometers apart. So that's the first thing that we need to pay attention to. If you have an east-west line, it's a horizontal line. So there's A, there's B, and we're told that they are 8.6 kilometers apart. Station A detects a plane at C on a bearing of 53 degrees. So what I need to do is say, okay, well here's due north, and I need to rotate clockwise 53 degrees. When I do that, here's my plane at C. At the same time, B detects the same plane on a bearing of 323 degrees. So again, there's my north-south line. I need to go 323 degrees to see that plane, which is how it ends up here, and my bearing, here's my 323. So we need to find the distance from B to C. So we're looking at the distance from B to the plane. Well, the first thing I need is the angles on the inside of the triangle. If I look at angle A, remember the north-south line is here, the east-west line is here, which means that this is a 90-degree angle, so I just need the complement of 53 degrees. So that's 90 minus 53, and I find that angle to be 37 degrees. Angle B is going to be a little bit trickier. The first thing that I'd like to do is find this angle here. I know a full rotation is 360. I can subtract out the 323. So that smaller angle is 37 degrees here. Well, I again need the complement of that for the inside of the triangle, and the complement of that is 53 degrees. What we can now do is find angle C. So if we do 180 minus 37 minus 53, we find that angle C is a right angle. So if we're looking for the distance from B to C, we can actually use our rules for right triangles to do that, meaning we can use SOHCAHTOA. Whether you would prefer to use sine or cosine actually doesn't matter. Remember that this 8.6 is actually your hypotenuse because it's opposite the right angle. I will choose to use the sine of 37, not for any particular reason, but the sine of 37 is going to be my distance from B to C. I'll just name that, you know what, so we'll call that A. So the sine of 37 is A over 8.6, and then from there we solve for A. 8.6 times the sine of 37 is equal to A. I get angle A is equal to 5.176 kilometers. Because this is a word problem, I write my answer in a sentence. The distance from B to C is 5.176 kilometers. For this bearing problem, we're using method 2, which means that we're given bearings as acute angles starting at either north or south and moving either in an east or west direction. So it says the bearing from A to C is north 64 degrees west. What that tells me is that C is above A and also to the left. So I'm actually going to draw A closer to the right-hand side. And if I move north 64 degrees west, I can place point C. From A to B, I need to move south 82 degrees west. Well, here's south. 82 degrees towards the left will be over here. And then the bearing from B to C is north 26 degrees east. Well, if I look at the location of these points, C is north and also to the east. So I know that I've sketched this pretty correctly. So I'll draw in my north line, and there's my east, and that is 26 degrees. The next thing it tells us is that if a plane flies from A to B at 350 miles an hour, it takes 1.8 hours to go. It doesn't seem like important information, but that's actually how we will get the distance from A to B. So if we look at that distance, we'll call it C because it's side C. That distance is equal to the rate times time. The rate is 350. The time is 1.8. So this gives us a distance for side C of 630 miles. The next thing that we can do is we can calculate the value of angle A within this triangle. Remember that this north-south line is 180 degrees, so we can subtract off the 64 and the 82. So that would be 180 minus 64 minus 82. That gives us 34 degrees. In order to find angle B within the triangle, you need to remember back to your geometry about parallel lines. So imagine this is one line, they're parallel, and they are cut by a transversal. This angle at 82 degrees and this angle here are same side interior angles, which means that they are supplementary. So if I want to find this outside angle, all I have to do is take the supplement of 82 degrees. Which gives me 98 degrees here. So now I can use that to find this angle on the inside of the triangle. Here, I'll write this in at 98. So that's 180 minus 26 minus 98. It gives me an angle of 56 degrees. I can use that to find angle C. Inside the triangle will be 180 minus 56 minus 34. And angle C is a right angle. Certainly not drawn that way in this picture, but it does calculate that way. So now again, if we're going to find the distance from B to C, I'll highlight that in blue, this distance here, we just have to use what we know about our right triangle trigonometry. So I will use cosine this time, not for any particular reason, but the cosine of 56 degrees will be side A, because it's BC, over 630. Remember again that if this is my right angle, my hypotenuse is opposite. So that's 630 cosine of 56 will give me side A. I get that side A is 352.292 miles. And I can say the distance from B to C This next problem is one that's quite common. We need to find the height of a building. From a given point on the ground, we find an angle of elevation to the top of the building at 74.2 degrees. She then walks back 35 feet. From the second point, the angle of elevation to the top of the building is 51.8 degrees, and we use that to find the height of the building. So the first thing we have to do is sketch this. The nice thing about buildings is that they're perpendicular. So our first angle of elevation is 74.2. Our second angle of elevation is 51.8. And we know that the distance between these two is 35 feet. We don't have the distance from the building to her first line of sight, so we just name it X. And what we can do is we can solve the trig ratios using X in order to find the height of the building, which I will call H. So the first thing that I will do is use this right triangle. I've got an angle, I've got opposite, and I've got adjacent. Obviously, it's not much to go on, but it's some place to start. So I can say that the tangent of 74.2 is equal to H over X. Then what I can do is look at this right triangle. My distance here is 35 plus X. My height is still H. So the tangent of 51.8 is equal to H over X plus 35. We'll say 35 plus X. My next step is to solve for H in both of these equations. So the red equation becomes X times the tangent of 74.2, and my blue equation becomes 35 plus X times the tangent of 51.8. Now one thing that's always true is that h is equal to h, meaning the blue height and the red height are equal to each other. So I can set the other sides of their equations equal to each other as well. And I get x times the tangent of 74.2 is equal to 35 plus x times the tangent of 51.8. Here is where it gets algebraic. We're pretty much done with the trig. So we have to start doing things like factoring and distributing. First thing that I will do is I will distribute this 35 plus x each to tangent. So I'll rewrite the left-hand side, x tangent of 74.2, and that's equal to 35 times the tangent of 51.8 plus x times the tangent of 51.8. The reason that I do this is because now I can collect these terms with x and put them together on the left-hand side, meaning I have to subtract this from both sides of the equation. That gives me x times the tangent 74.2 minus x tangent 51.8, and that's equal to 35 tangent 51.8. From here, on the left side, I'm multiplying each term by x. That means that I can factor x out. Factoring, remember, is undistributing. So you have x tangent 74.2 minus tangent 51.8, and that's equal to 35 tangent 51.8. At this point, I'm nearly done. The thing that's difficult to recognize is that you are now multiplying x times this whole piece. So in order to isolate x, I actually need to divide by everything in parentheses here on the left-hand side. When I do that, my numerator becomes 35 tangent 51.8. My denominator, and when you put this into your calculator, make sure you use parentheses, is tangent of 74.2 minus tangent of 51.8. This whole thing will go directly into my calculator. I will most likely put parentheses around the numerator as well so that my calculator doesn't mess up order of operations. And I calculate that x is equal to 19.653. Now remember, that's not what the question was asking. It asked for the height of the building. So when I go back, I remember that I had this right triangle. This was the 74.2 degrees. Here was x. Here was the height of the building. So now I have a value of x. And from the previous slide, we also had the ratio, the tangent ratio, that tangent of 74.2 was equal to h over x. In this case, that would be h over 19.653. So I can solve that. 19.653 times the tangent of 74.2 is equal to our height. And I learned that the height of the building is 69.452 feet. Of course, I write this as a complete sentence. Now I just got a phone call that we do not have class on Friday, You still have to watch this video, but I do hope that you've enjoyed your day off.